Hello and welcome back. Today I'll be going over how to add and subtract fractions. In order to add two fractions together, they need to have the same denominator. Just to recap, the top number of a fraction is known as the numerator, and the bottom number is known as the denominator. When we add two fractions together with the same denominator, we simply just have to add the numerators together, and we keep the denominator the same. This concept is even seen when doing basic addition. Let's say, for example, we have 5 plus 1. 5 plus 1 is the same equation as 5 over 1 plus 1 over 1. Both fractions here have the same denominator, so we can just add the 5 plus 1 and keep the 1 as our denominator and have 6 over 1 as our final answer, or 6. This works the same way for subtracting. Our equation for our next problem is 3 over 4 minus 1 over 4. Both the denominators are the same, meaning that we just have to do 3 minus 1, which is equal to 2. Our final answer would be 2 over 4. Now, what if our denominators aren't equal? Let's look at this problem over here. We have 3 over 4 minus 1 over 6, and we need to solve this. If we think about what we have to do in order to subtract fractions, we know that we need to have the same denominator for each fraction, and we can do this by finding the lowest common multiple for each number. Now, how do you find a lowest common multiple, and how will it help? For example, if we have the equation 1 over 4 plus 1 over 2, what we would have to do is we would have to list out the multiples of both the 4 and the 2. The multiples of 2 are 2, 4, 6, and 8. And the multiples of 4 are 4, 8, 12, and 16. Notice how the first common multiple in 2 and 4 is 4? Now, what we have to do is to make each fraction in the equation have a denominator of 4. The 1 over 4 already has a denominator of 4, so we can just leave that there. However, we need to turn the 1 over 2 into a fraction with 4 as the denominator. To do this, we need to see how much we have to multiply 2 by to get 4, which we know is 2. However, we can't just leave the numerator alone. We have to multiply the fraction 1 over 2 by 2 over 2, giving us 2 over 4. If you didn't already know, to multiply two fractions together, you simply multiply the denominator by the denominator and the numerator by the numerator. You might be wondering, why do we multiply both the numerator and the denominator by the same number? This is to ensure that we aren't changing any values in the equation. By multiplying the equation in this case by 2 over 2, we're still essentially multiplying it by 1, meaning we aren't changing any values. This makes it easier to add the fractions, as 1 over 2 is still the same as 2 over 4. This may have been a lot to take in, so let's use this in our main problem. The factors of 4 are 4, 8, 12, and 16, and the factors of 6 are 6, 12, 18, and 24. Notice how the first common factor is 12? We can use this as our lowest common multiple. To change our 3 over 4 into a fraction with the denominator of 12, we need to multiply our denominator of 4 by 3. So we do 3 over 3 multiplied by 3 over 4 to give us 9 over 12. To get our 1 over 6 to a fraction with a denominator of 12, we multiply it by 2 over 2, giving us 2 over 12. Now we have 9 over 12 minus 2 over 12. Since we have the same denominators, we can subtract the numerators, giving us 7 over 12 as our final answer. That may have seemed like a lot, but it's really just a couple of steps. Let's try another problem. 1 over 2 plus 2 over 3. Well, first of all, we need to find out what our denominator should be. The multiples of 2 are 2, 4, and 6, and the multiples of 3 are 3, 6, and 9. Notice the common 6 shared? We can use that. We can do 1 over 2 times 3 over 3 to get 3 over 6, as 2 times 3 is 6. For the second fraction, we can just do 2 over 3 times 2 over 2 to get 4 over 6. We now have 3 over 6 plus 4 over 6. 3 plus 4 is 7, so our final answer is 7 over 6. Once you know the concepts, it's so much easier to add fractions like these. Now, for a harder question, we're going to have to solve for a variable. Our next question is 2 over 5 plus x is equal to 2 over 3, and we have to find the value of x. Feel free to pause the video and try solve this on your own. Okay, let's begin solving this. In order to find the value of x, we need to make sure it's on one side of the equation. In order to isolate a number or variable, we subtract and move everything on the side of the variable to the other side. In this case, we would have to move the 2 over 5 to the side of the 2 over 3. Now, how would we do that? We would subtract it on both sides. We can't just subtract it on one side. That'd ruin the equation completely. We subtract 2 over 5 on the left side and subtract 2 over 5 on the right side. 2 over 5 minus 2 over 5 is just 0. So our equation just becomes x is equal to 2 over 3 minus 2 over 5. Let's use what we learned to try solve this equation. The multiples of 3 are 3, 6, 9, 12, and 15. And the multiples of 5 are 5, 10, and 15. Our matching multiple is 15. To get 2 over 3 to a denominator of 15, we multiply it by 5 over 5 to get 10 over 15, and we multiply the 2 over 5 by 3 over 3 to get 6 over 15. We then simply do 10 over 15 minus 6 over 15 to get 4 over 15 is equal to x as our final answer. For my last question, I'm going to mix it up a bit with a word problem. Jimmy walked 2/3 of a mile from his home to his school. After his school ended, he walks to a nearby shop, which is 3/7 of a mile away from his school. How far did Jimmy walk in total? Well, to know how far he walked in total, we would have to add up these small intervals. We know that he walked 2/3 of a mile to his school and 3/7 of a mile to a shop. So the distance he walked is 2/3 plus 3/7. Let's use what we know to solve this equation. First, we find the lowest common multiple. The multiples of 3 are 3, 6, 9, 12, 15, 18, and 21. And the multiples of 7 are 7, 14, and 21. Our matching multiple is 21. Let's see what we can do with this. 3 times 7 is 21, so we multiply 2 over 3 by 7 over 7, giving us 14 over 21. And we multiply 3 over 3 by 3 over 7, giving us 9 over 21. We simply then have to do 14 over 21 plus 9 over 21, giving us 23 over 21 as our final answer. Jimmy has walked 23 over 21 miles so far, which is just over 1 mile. Thank you for watching, and if you have any questions, feel free to leave them in the comments.